In this video, we'll be going over surrounded regions. So given M times N matrix board containing X and O, capture all regions surrounded by X. A region is captured by flipping all O's into X in that surrounded region. So in our first example, we're given this board, and then we have the cells OO over here, and then which is surrounded by X. If it's surrounded by X, we want to convert it into X, as we can see here. And then this cell here is not surrounded by X because there's no X here, so it stays at O. As we can see, all of the cells with a value of O that is at the borders cannot be flipped, and then any cell that's connected to the current cell here cannot be flipped. So for example, if this cell here, X, is actually an O here, if it's an O here, this means it cannot be flipped because it's connected to an O at the borders. Let's go over the thought process. So for each of the cells which contains a value of O that is at the borders of the matrix cannot be surrounded by X, then any of the cells which contains a value of O that is also connected to a O at the borders can also not be surrounded by X. We can perform two scans on the input matrix. The first scan will check for O's that is connected to the borders. Then the second scan will the first scan is we will check for the borders. We will mark all of the cells which contains a value of O and also connected to the borders to U. This means unflippable. If it's connected to the border which contains a value of O, it is unflippable, so we're going to set it to U. And then the second scan will flip the cells. So any cells with a value of O will be changed to X. This is because it's surrounded. And then any cells with a value of U will be changed back to O. Now let's go over the pseudocode. So we're going to validate the input parameter first. If board is empty, we can just return from the method because there's no cells to flip. Now we'll first perform our pre-scan to check for O's that's connected to a borders which also contains values of O. So we're going to iterate through the first row first. Iterate through the rows. We're going to be checking through the first column and also the last column. So basically these cells here. So we're going to iterate through the rows. Denote it as R. We're going to perform a recursive depth first search on the current row and also the current column, which is 0. And then we're also so we are going to create we're going to create a helper method to perform this recursive depth first search for the marking. So let's implement it. So what parameters do we need? We will need R, the current row, and C, the current column. So this is going to initially be 0. And then we're going to hit the input board. Then what's the base case? If R and C is out of bound or does not contain a O, we can just return from the recursive call because we cannot mark it into unflippable. Then in each of the recursive call, we're gonna set the current for RC to U because it cannot be flipped because we're going through the borders and if the current cell contains an O, this means it cannot be flipped. Now we want to iterate through the 4 directions. Denote that as D, which is top, right, bottom, left. We'll perform our recursive depth first search because it's connected to the current cell. Then we're going to recursively traverse in that direction. So R turns to R plus D0, the current direction, the current delta direction, and then C is C plus D1. And then this recursive depth first search will mark all of the cells that's connected to a border, which also contains an O. Now, in this case, we'll perform a recursive depth first search on the first column. Now we want to perform a recursive depth first search on the last column. So which is board r.length minus 1, which is the last column. This recursive depth first search is the same as here, so we are not going to be rewriting this. Now we're going to iterate through the columns. This time we want to mark all of the first rows and also the last row. So similar process, denoted as C this time. Then we're going to perform a recursive depth first search on the first row and also the current column. Similar here. Now we're going to perform another recursive depth first search on the last row. So board.length minus 1 and C. Now we have finished performing our first scan. Now we want to perform our second scan, which basically changing the values of O to X, which means the cells that are surrounded by X, and also changing all the values of U back to O. Then we want to iterate through the rows and columns of board. We can denote it as RC. Now if board RC is equal to O, we want to set it to X. Now if board RC is equal to U, we want to set it back to O. And that's it. Now let's go over the time and space complexity. The time complexity is the first one, we iterate through all the rows, the first row and the second row, the first row and the last row. So it's O of 2R plus 2C because we iterate through all the columns. But the next one is we perform a recursive depth first search. Worst case scenario, we flip the entire board. So it's R times C. And then the second one, we just perform the first, and then the second scan, we just iterate through the whole board. So it's just R times C. So we get O of R times C, where RC is the number of rows and columns. So this one is marking unflippable cells. And then the second one is converting cells. And then the space complexity is of R times C, which is the recursive call stack memory, because we perform our recursive depth first search in this case. Worst case scenario, we mark the whole board. So recursive call stack memory. Now let's go over the code. So we'll first validate the input parameter first. If board.length is 0, we just return. There's no cells to mark. Now we want to first mark all of the unflippable cells. We'll first iterate through the columns. So if we want to iterate through all the columns here, in this case we iterate through all of the rows. So, and then we check the first column and also the last column. So let's iterate through all the rows. And then we want to recursively mark the unflippable cells. RC, the current column, starting column is 0. And so the input board, and we also mark the last column in the board, and then we iterate through all the columns to mark the first row and the last row. So similar process. In this case, we change R to 0, and then the column to C, and then the row to the last row, and also the column. Now we will implement our recursive depth first search approach to mark all the cells with a value of O that's connected to a cell with also a value of O at the borders. And it's R in row and also the input board. Now we first check our base case if R sees out of bound. Or if the current cell does not contain a O, then we just return from the recursive call. Now we want to mark the current cell to U because it cannot be flipped. The current cell contains a O, so it cannot be flipped. Now we want to iterate through the 4 allowed directions. And then we're going to recursively mark the surrounding cells. So this is our directions matrix, which allow us to go through the 4 directions. So the first direction is -1, 0, which is going upward. And the next direction is 1, 0, which is going downward. And then our next direction is going leftward, and then our next direction is going rightward. Now after we mark all of the cells that are unflippable, we want to convert it back. We want to convert all of the cells with a value of O to X, and then convert all of the cells with a value U to O. So this means we want to iterate through the rows and columns again, our second scan. And then if the current cell contains an O, we want to set it to X. And then if the current cell contains a U, we want to set it to O again. Let me know if any questions in the comment section below.